Emollients. They replenish oils and lipids in the skin. They soften and smooth the skin by filling void spaces on the skin surface and replacing lost lipids in the stratum corneum. They also provide protection and lubrication on the skin surface, minimize chafing, and enhance the skin's aesthetic properties. Examples of emollients used in cosmetics and cosmeceuticals products include vegetable oils and fats, polymers, silicants. Before we start talking about vegetable oils and fats, I am going to explain the chemistry behind oils and fats. In chemistry, chemical bonds are interactions between atoms that hold them together to form molecules or compounds. These bonds are essential for determining the structure, properties, and reactivity of substances. There are several types of chemical bonds, including covalent bonds, ionic bonds, and metallic bonds. Two important types of covalent bonds are sigma bonds and pi bonds. Sigma bonds. Sigma bonds are the strongest and most stable type of covalent bonds. Pi bonds. Pi bonds are weaker than sigma bonds and are typically formed in addition to sigma bonds in double and triple bonds. Saturated oil contain fatty acids with only single sigma bonds between carbon atoms, resulting in a straight, linear structure. Each carbon atom in the fatty acid chain is bonded to the maximum number of hydrogen atoms possible, leading to a saturated arrangement. In saturated fatty acids, all the bonds between carbon atoms are sigma bonds. Examples of saturated fatty acids commonly found in oils include palmitic acid 16-carbon, 0 double bond, and stearic acid 18-carbon, 0 double bond. Unsaturated oil contain fatty acids with one or more double bonds between carbon atoms, resulting in a bent or kinked structure. These double bonds consist of both sigma bonds and pi bonds. The first bond between the two carbon atoms forming the double bond is a sigma bond, similar to those found in saturated fatty acids. The second bond is a pi bond. Examples of unsaturated fatty acids commonly found in oils include oleic acid 16-carbon, 1 double bond, and linoleic acid 18-carbon, 2 double bonds. Now here's the thing. In most cases, the saturated is fat due to the sigma bond, and the unsaturated is the oil due to the pi bond or bonds. Vegetable oils are sources of saturated, monounsaturated, and polyunsaturated fatty acids. Fatty vegetable oils, triglyceride, are valuable components of medicinal and cosmetics. As a part of cosmetic compositions, vegetable oils carry out, as a rule, some functions. They play the role of emollients, serve as a base in which other structural and functional components of the composition are located, perform a transport function of delivery of biologically active substances through the lipid barrier of the skin. The triglycerides of fatty acids, which form the basis of vegetable oils, are actively involved in the formation of structure, function, and repair of cell membranes of the lipid barrier. When formulating a cosmetic product, it is beneficial to prioritize the use of triglycerides that mimic the composition of the skin's natural lipid barrier, as this can have a positive impact on the product's efficacy. Specifically, incorporating triglycerides found in the lipid barrier of normal, healthy skin, along with their natural proportions, is recommended. The human epidermis naturally contains a mixture of fatty acids with prominent proportions including linoleic 18 carbons 2 double bonds, 21.5%, oleic 18 carbons 1 double bond, 15.1%, palmitic 16 carbons 0 double bond, 14%, stearic 18 carbons 0 double bond, 11.1%, and lignoceric 24 carbons 0 double bond, 10%, acids. To use them in cosmetics, the alkyl compositions should be understood, and appropriate oil should be selected based on purpose, because the feel of use is determined by the alkyl composition and melting point. Vegetable oils and fats are especially prone to oxidization and changes in color by light, oxygen, and heat because the alkyl group has unsaturated fatty acids, which have a double bond, bonds prone to oxidization. The iodine number is a useful index for knowing oxidization stability. Oils and fats that contain linoleic acid, which have 3 double bonds, have large iodine numbers and are especially prone to oxidization. Care should be taken in using natural fats and acids that have linoleic acid and large iodine numbers, and it is recommended to lower the pH or add antioxidants such as vitamin E and lecithin. Oils and fats that contain lauric acid and or myristic acid, which have short alkyl chains, give a light touch. Solid fats that contain large amounts of palmitic acid and or stearic acid reduce lubrication. Liquid oils rich in unsaturated fatty acids, such as oleic acid, give a moisturized feeling. It is easy to understand the properties of the vegetable and animal oils and fats, which helps designing cosmetics formulations by classifying them by the length of the saturated alkyl chains, iodine number, and the distributions, and contents of unsaturated acids, such as oleic, linoleic, and linolenic acids. Vegetable oils and fats rich in linoleic and linolenic acids. Soybean oil and sunflower oil, which contain about 10% linolenic acid, have low melting points. Antioxidization measures should be taken when using them in cosmetics because the iodine number is large. Rapeseed oil has a relatively small iodine number because it contains more oleic acid than linolenic acid. Vegetable oils and fats rich in oleic and linoleic acids. Safflower oil, which contains as much as 77% linoleic acid, and cottonseed oil and maize oil, which contain about 55% linoleic acid, require measures for preventing oxidization. Oils extracted from sesame and rice bran contain about 40% linoleic acid and 40% oleic acid and can be used in a large quantity in cosmetics by taking oxidization preventive measures. Vegetable oils and fats rich in oleic acid oils extracted from avocado, olive, camellia, and rice bran and persic oil contain at least 70% oleic acid. They have relatively low iodine numbers of 80 to 110 and are stable against oxidation and are thus suitable for cleansing and massage oil products, to which a large amount of oil must be prescribed because they give a moderate moisturized feeling. Antioxidants such as vitamin E and its derivatives are essential for products mainly consisting of oils, and the long-term stability must be checked. The oils can be added in creams by lowering the pH to the lowest level. They give a moderate moisturized feeling. Vegetable oils and fats rich in lauric acid. Coconut and palm kernel oils contain approximately 50% lauric acid. They are prone to producing a unique sweet smell, and the stability should be confirmed before use. Solid oils give a light and dry feeling but are not widely used. Vegetable and animal oils and fats, mainly consisting of oleic and palmitic acids. Palm kernel oil, which contains about 50% palmitic acid and 40% oleic acid, melts at 45 degrees Celsius and is solid at room temperature. It has a small iodine number and is stable against oxidation. Because it is solid fat, it gives a relatively heavy touch and reduces lubrication. It is not suitable for cosmetics that need to be soft and smooth. However, it is useful for giving a light and dry feeling and is suitable for hand creams and other non-silky products. Vegetable oils and fats containing palmitoleic acid. Macadamia nut oil is a rare vegetable oil that contains 25% palmitoleic acid. It has a small iodine number, a low melting point, and relatively high oxidation stability. When used for hair care products, it provides a moisturized and soft feeling. It is an easy-to-use vegetable oil. Vegetable oils and fats containing ricinoleic acid. Castor oil contains approximately 90% ricinoleic acid and is highly viscous. Because of the heavy feeling, it is unfavorable for skin care products that need to be refreshing. Inclusion of several percent is suitable for leave-on hair treatment products that aim for giving a strong moisturized feeling. Vegetable oils and fats containing oleic and stearic acids. A typical fat of this group is shea butter. It contains 65% oleic acid and 20% stearic acid. It gives a moisturized and relatively heavy touch. Due to its small iodine number, it is stable against oxidization. It is useful for giving a moderate moisturized feeling to skincare and hair care products. Vegetable oils and fats containing eicosanoic acid. Meadow foam seed oil consists of long-chain fatty acids of about 60% eicosanoic acid and 15% erucic acid. It is stable against oxidization and gives a moisturized and persistent feeling. Silicones is the name given to organic silicon compounds containing the siloxane chain. Silicones are commonly used as emollients in cosmetics due to their unique properties and versatility. Silicones are a group of synthetic compounds derived from silicon, a naturally occurring element, and oxygen. They are valued in cosmetics for their silky smooth texture, spreadability, and ability to form a protective barrier on the skin without clogging pores. A typical example is dimethicone. The silicones are available in a wide range of viscosities. Silicones are highly hygroscopic, and they have none of the sticky feeling found in hydrocarbons, so they have good feeling on use, making them suitable for a wide range of applications on skin. Dimethicone is one of the most widely used silicones in cosmetics. It is a lightweight emollient that provides a smooth and silky feel to the skin. Dimethicone forms a breathable barrier that helps to lock in moisture and prevent water loss, making it particularly beneficial for dry or sensitive skin. It is commonly found in moisturizers, primers, foundations, and hair care products. Dimethiconol is a silicone derivative of dimethicone that provides long-lasting moisturization and skin conditioning benefits. It forms a protective barrier on the skin surface, helping to prevent moisture loss and improve skin texture. Polymers. Polymers are widely used in cosmetics, mainly for thickening and also for stabilizing and improving the feel of use. The viscosity of polymers depends on the molecular weight, and the chemical structures of the hydrophilic group and alkyl chain determine the properties. The higher the molecular weight of polymer, the greater the thickening. Various polymers are used in cosmetics. They can be classified by the ionization state of the hydrophilic group into anionic, cationic, non-ionic, and amphoteric polymers. Polyethylene glycol, PG, is a polymer compound derived from ethylene oxide and water. It is used in skincare products as emollient due to its ability to attract and retain moisture in the skin. PGs are commonly found in creams, lotions, and moisturizers. Polyethylene glycols are stable, hydrophilic substances that are essentially non-irritant to the skin. They do not readily penetrate the skin, although the polyethylene glycols are water-soluble and are easily removed from the skin by washing, making them useful as ointment bases. Polyvinylpyrrolidone, PVP, is a polymer compound used in skincare products as a film-forming agent and emollient. It forms a flexible film on the skin surface, providing a smooth and velvety feel. PVP is often used in moisturizers, sunscreens, and anti-aging skincare products.